So today we're going to start our solving equations unit, and we're going to actually just look at solving linear equations. It's something that most of you will have seen in grade 8, but it's a little bit of a review today. The lessons after this, though, of course, will get challenging. So I just want to go through a few kind of little examples to start off with. And the question is, are the following linear equations true, false, or neither? If the left-hand side does not equal the right-hand side, then unfortunately it is not true. So if we look at the first one on the, on the left-hand side, we've got 4 plus 3, which all of you are probably saying is equal to 7. And on the right-hand side, we have 7. Therefore, they're equal, and this means that our equation is true. The second one, we've got 7 minus 3 on the left-hand side, and on the right-hand side, we have 5. So 7 minus 3 is 4, and unfortunately, this does not equal 5, and therefore we would say that this is false. The next one, we have 3 multiplied by 4 is equal to 12. Well, 3 multiplied by 4 is equal to 12, and 12 equals 12. Therefore, this is true. And the last one, we have x plus 2 equals 7. Now, at the moment, we don't know what x equals. So, x is equal to, I'm not sure. So somebody could say, okay, well, x is equal to 9. Well, 9 plus 2 is 11, so that would be false. So in fact, this one at this point is neither. If x equals 5, then this would be true. But at the moment, we're not sure what x is, and therefore, at the moment, it is neither. Okay, so we're going to look at a really nice easy one to start off with. We actually want to solve these now. So we want to find out what x is to make this equation true. Now, I'm sure most of you are saying right now, okay, well, obviously x is 3 because 3 plus 2 is 5. So this one is pretty easy. 3 plus 2 equals 5. So that means that x must equal 3. If we solve this by showing our algebraic steps, notice that what I could do is I could subtract 2 from both sides, because as we remember, whatever I do on one side of the equation, I must also do on the other side of the equation, and therefore I get x all by itself, and x is equal to 3, and of course both of my answers would be correct. To solve the equation 3x equals 5. Now again, I want to know what x equals, so I want x equals something. Alright, so right now we have 3, and there's an implied multiplication there is equal to 5. I'm doing the opposite operation, so right now 3 multiplied by x. The opposite operation to multiplication would be division. Notice that if I divide this side by 3, then 3 divided by 3 is equal to 1. And whatever I do to one side, I must also do to the other side. So this becomes x is equal to 5/3. Of course, the nice thing about this unit is we can check. Okay, so if I have 3x is equal to 5, if I substitute x in, 5/3, this is equal to 5. Remember, this is the same thing as 3/1. We can cross simplify, so we've got, that becomes 1s, and I get that 5 equals 5. So, yep, I did it correctly. Now, the first one and second one were pretty easy, but just know that you're able to check on all of these solutions throughout the unit. Alright, our next one, we've got a few more steps. So I'm going to show you 2 methods. Okay, they're pretty much the same. One I'm going to do 2 steps, and one of them I'm going to do it in 1 step. So the first thing, notice that I've got -2 divided by 3 multiplied by x equals 6. Again, I'm trying to solve for x equals. I want to know what x equals to make this equation true. Notice that if I multiplied this by 3, okay, whatever I do to one side, I do to the other. It's nice because now this is like 3/1, and those 3's cancel out, and we get -2x is equal to 6 times 3 is 18. Again, I'm trying to solve for x equals, so I could divide both sides by -2, and the negative divided by a negative becomes positive, 2 divided by 2 becomes 1, so I get that x is equal to -9. So essentially method 2 is very similar, but I'm going to do it in one step. So again, I've got negative 2 over 3x is equal to 6. Well, all I did in that step is I said, okay, well, I need to get rid of this 3. So how can I make that 3 become a 1? Well, if I multiply both sides by 3, then essentially that 3 is going to become a 1. And if I divide this side by negative 2, then this piece over here that I just highlighted, negative 2 divided by negative 2 becomes a 1. I also have to divide the other side by negative 2. Okay, so all that I'm left with on my left-hand side is x, and on the right-hand side I have 6 times 3 is 18. 18 divided by negative 2 is negative 9. So instead of doing it in 2 steps, I did it in 1 step. What I want you to notice from this side is that if I erase all of my, get rid of some of the stuff, essentially I had negative 2/3 over here. Okay, and notice that what I multiplied by was the opposite, or the reciprocal, so 3 over negative 2. So I've just flipped that, I flipped this, and I multiplied by it. And I have to do whatever I do on one side, always have to do on the other side. Now we can check this. Okay, you can always check. So we've got negative 2 over 3x is equal to 6. Well, x is equal to negative 9. We just solved to make this true. So I'm going to multiply by negative 9. It has to equal 6. This is the same thing as 9 over 1. I'm going to cross reduce here. This becomes a 1. This becomes negative 3. Negative 2 multiplied by negative 3 is positive 6, which is equal to 6. Yes, I did get it. Alright, we're going to add some more steps, and I believe this is going to be the last one for today. So again, it's just some nice simple review. I'm just going to do one method here. So we've got 5x minus 4 is equal to 2x minus 1. Okay, so remember, my goal is to get x equal to one number, and the number is significant because it makes the right-hand side equal the left-hand side. We want this number will be to make it true. And so the first thing I'm going to do is I'm just going to add this 4 to both sides, because I notice that there's a lot of things going on. Let's just make it go away from this side. So now I've got 5x on this side, 2x plus 3. And again, I don't have x equals because I've got an x on both sides. So I'm just going to bring this one over here to the other side. And I want to get rid of it. So 2x minus 2x becomes 0 on that side. And 5x minus 2x becomes 3x on this side is equal to 3, as this is left over here. And then now I have 3x equals 3. So I'm getting closer to my goal of x equals something. So I'm going to divide both sides here by 3, because 3 divided by itself is 1. So that's nice. That goes away. And I get x equals, and it happens that 3 divided by 3 on this side is 1 as well. Alright, so let's check it. Checking it is good. My question started off as 5x minus 4 is equal to 2x minus 1. I'm going to check it for when x equals 1. Wherever I see an x, I'm substituting that 1. So I've got 5 multiplied by 1 minus 4 is equal to 2 multiplied by 1 minus 1. Well, 5 times 1 is 5, take away 4 is equal to 2 multiplied by 1 is 2, take away 1. Well, 5 minus 4 is positive 1, 2 minus 1 is positive 1, 1 does equal 1. Yes, I got my answer, which is x equals 1. Alright, and that is our first solving equations lesson.